Good morning. We are going to be going through the answers in warm-up 12, day 8 today. And rather than trying to switch between showing you the answer key like I normally do, I'm just going to go ahead and work through each of the problems, and then you can check your answers as we go along. I know it takes a little bit more time to do it this way, but feel free to scroll through the video if you are looking just for like the answer to one problem. So we're going to start with number 1. Which decimal is 87.9834 rounded to the nearest thousandth? So our keywords here are nearest thousandth and rounded. Remember our places, we go the decimal point, and then we have our tenths and our hundredths and our thousands and then our 10,000ths. So if we are wanting to round to the nearest thousandth, we've got to look at our 10,000th to decide if we go up or if we stay the same. So in this case, 87.9834, our thousandth number is 3, but our 10,000th is the one we want to look at. So since it is a 4, this 3 stays the same. If it was 5 or more, we would round up. So we are looking for 87.983. Number 2, the solution to the equation 9x minus 24 equals 12. We're simply solving for x. So 9x minus 24 equals 12. The first thing I want to do is get rid of this negative 24. So to cancel out a negative 24, I need to add 24. But if I'm going to add 24 on this side, I need to add 24 on this side. So 24 plus 9x minus 24 gives me just 9x. And 12 plus 24 is 36. Now I have 9 times x, and I want to cancel out that 9. So I need to divide by 9. 9 times x divided by 9 gives me just x. But if I divide by 9 on the left, I have to divide by 9 on the right. So that gives me x equals 4. Number 3, I'm looking for a pattern sequence. This pattern, we'll take it over here, is I add 7 and then I subtract 4. And because it's a sequence, it means that I would keep doing that. So in letter A, 7 to 14, yeah, I'm adding 7. 14 to 21, I'm adding 7 again. So that's not my sequence. B, 0 to 7, I'm adding 7. 7 to 3, I'm subtracting 4. 3 to 10, I'm adding 7. 10 to 6, I'm subtracting 4. 6 to 13, I'm adding 7. 13 to 9, I'm subtracting 4. So there it is, right there. So it's just a matter of figuring out what my sequence is and then trying out my numbers to see where it matches. Okay, so that is 1, 2, and 3. I'm going to go ahead and erase it. And scroll down to number 4. mechanic charges a flat fee of $60 to inspect a car plus $30 per hour to repair it. So remember, this per hour is a unit rate. It would be $30 for each hour. So if it's 1 hour of work, it would be 30. If it's 2 hours of work, it would be 60. That's what we call rated amount. It has a rate to it. It's not just a flat amount. So H equals the number of hours, which expression can be used to find the cost of any number of hours the mechanic spends repairing a car. Well, 60 is my one-time fee, and 30 per hour is my rated amount. So the only one that has both of those numbers is this one. There's my 30 per hour, and there's my one-time fee. The cost to repair Steve's car, we're in Part B now, was $210. How many hours did the mechanic spend repairing the car? So we can make this expression into an equation. 30H plus 60 equals my total cost, 210. And then I'm just solving for H. So the first thing I want to do, I've got a positive 60 that I want to cancel out. So I put a negative 60 on both sides. I don't really need that line right there. Negative 60 plus 30H plus 60 would just give me 30H. And then 210 minus 60 would give me 150. Then 30 times H, if I want to cancel out that 30, I've got to do the opposite of times, which is divide. And that gives me H. But if I divide by 30 on the left side, I've got to divide by 30 on the right. And 150 divided by 30 is 5. So he worked 5 hours on that car. All right, I'm going to go ahead and erase this. And then I will scroll down to the next one. Okay, number 5 is a wording problem. We've got our number lines, and we have these closed dots, and we have these open dots. Remember, if it's a closed dot, it can be equal. So it could be less than and equal to or greater than and equal to. If it's an open dot, it's just going to be less than or greater than. So Hans wants to spend at least $3 on a gift for his mother. Which number line represents this scenario? Well, first we need to decide, do we need a closed dot or do we need an open dot? He wants to spend at least $3, means that $3 is okay. It's included. So that means we want a solid dot. So we can say no to C and no to D. The next thing we have to look at, he wants to spend at least $3. So $3 is okay, but he's also okay with spending more. $4 is okay. $5 is okay. But if he wants to spend at least $3, then $2 is not okay. So we are looking for a number line that has a closed dot at 3 and then contains the numbers 4 and 5 and keeps going. And that is answer A. For answer B to be correct, we would have to say Hans wants to spend no more than $3. So $3 would still be included, but he doesn't want to spend any more than $3 would look like this one. All right, I'm sorry for all of the scrolling, but right now with the way the BenQ has been glitching, this is the best way that I can keep things fluid. So I'm going to scroll down to the next one. Number 6, the graph shows a fenced area for a dog. Each grid represents 1 foot. And as you can see on here, the dots don't quite connect, but that is more picture error than the graph error. So imagine that it goes all the way down to this line and to that point. So Jessie says that she needs about 19 feet of fencing. Which statement is true? Remember, if we're looking at fencing or border, we're looking at perimeter. And perimeter is the sum of all sides. So we want this side plus this side plus this side. And we need the perimeter to be approximately 19 feet. Well, if it's a perimeter question, then I need to know some side lengths, right? So if I count for this side, if I count 1, 2, 3, 4, 5, 6, and I count for this side, 1, 2, 3, 4, 5, and I recognize that I've got a right triangle, then I can use Pythagorean theorem to figure out this side. We're going to call that C, because remember with Pythagorean theorem, a squared plus b squared equals c squared. A and b are my legs. That's this 5 and this 6, and c is my hypotenuse. So a squared can be 5 squared plus b squared can be 6 squared, but I still don't know c. That's what I'm trying to find out. So I'm going to keep that at c squared. So then I do some math. 5 squared is the same as 5 times 5, so that's 25. Plus 6 squared is the same as 6 times 6, so that's 36, equals c squared. Then I add these two together, 25 and 36, and I get 61 equals c squared. Now 61 is not a perfect square, so what this is going to give me is some kind of crazy decimal number. But in my question, I've got this beautiful word about, and about is the same thing as approximately. It gives us permission to estimate. So I've got a perfect square that is really close to 61. If I go to 64 is approximately c squared, then I can figure out what c is approximately. So if I take the square root of c squared, I get c. If I take the square root of 64, I get 8. 8 times 8 is 64. So the square root of 64 equals 8. Okay, so now I know all 3 side lengths, which means I can find my perimeter. 8 plus 5 plus 6 is 19, and that is how much fencing she says she needs. So I solved the problem, but now I need to figure out which statement reflects what I just did. So in the first one, Jesse is correct since the area is 15 square feet, which is close to 19. Well, we're not solving for area. We haven't been talking about area at all in this problem, so that's not right. Letter B, Jesse is correct since the length of the third side is the square root of 61, which is between 7 and 8, and 5 plus 6 plus 8 equals 19. Yeah, that is exactly what we just did. All right, so our answer is B because this is our perimeter, right? 5 plus 6 plus 8 is 19. That is just what we did. Okay, that's a little bit messy. So I'm going to go ahead and erase this. Remember, you can always go back and pause if you need to look at something that we've done. And now I'm going to go on to 7. So for 7, you want a scientific calculator like what we have in the classroom. That TI-30XS is that blue and off-white calculator. And Miss Laura can show you, if you don't remember, how to do scientific notation on that calculator. Or I'm going to leave a copy of the calculator tips, that two-sided document, and you can see how to do scientific notation on there, because you're definitely going to need to use it. Okay, but first let's create our equation. 2 years ago, Jordan flew 7 times 10 to the 5th miles in an airplane. 7 times 10 to the 5th, that equals 14 times as many miles as he flew last year. How many miles did Jordan fly last year? So let's make those miles that Jordan flew last year be X. So this is my equation. And before I put it into my calculator, I need to get X by itself, right? So to get X by itself, I'm going to divide both sides by 14. So what I am inputting into my calculator is 7 times 10 to the 5th divided by 14. And once you put it in your calculator in scientific notation mode, you should get 5 times 10 to the 4th as your answer. Okay, so that is number 7. Number 8, in 4 plays, the Giants football team runs 8 yards the first play. They lose 4 yards the second play. They lose 3 more yards the third play, and they gain 6 yards. So in football, you've got your defense and your offense is trying to gain 10 yards, at least 10 yards in 4 plays. So what this question is asking is, did the Giants do it? Were they able to get at least 10 yards in these 4 plays? So all we're doing is adding. We've got 8 yards, and then our next one we have -4 yards, then we have -3 yards, and then we have +6. So we can clean this up again a little bit, right? 8 plus a negative number is the same thing as just keeping the negative sign. Plus a negative number, same thing, just keep the negative sign. So if I have a positive, if I'm adding -4, it's the same thing as just saying -4. And if I'm adding -3, it's just the same thing as saying -3 plus 6. 8 minus 4, because remember with PEMDAS, if we're doing adding and subtracting, we start at the left and we work our way to the right. So 8 minus 4 is 4. Then 4 minus 3, these guys just came down, right? 4 minus 3 is 1. This guy just keeps coming down. And then 1 plus 6 is 7. So they had a positive 7 yards between those 4 plays. That was not enough to keep possession. They had to have at least 10. So did the Giants keep possession of the ball? No. Which means we can go ahead and cross off A and B as potential answers. Now we just need to look between C and D. Which one of these answers reflects what we just did in our calculations? So letter C, no, the team gains 7 yards because 8 plus negative 4 plus negative 3 plus 6, and then they're just mathing it out, right? They get to 7, which is less than 10 yards. C is our answer. Let you look at that. Remember to press pause if at any time you need to stop and write things down. And we're going to go on to number 9. Sayama is painting a wall in her dining room. The wall is a rectangle and measures 14 feet long and 9 feet tall. There are 2 windows, each 3 feet wide and 4 feet tall. What area of the wall does Samaya need to paint? Sayama. Okay, so figuring out what she needs to paint, the area to paint would equal the total area minus the windows area, right? So my total area of a rectangle is width times length. Let's draw a picture. So it's 14 feet long and 9 feet tall. And it has 2 windows in it that are 4 feet tall and 3 feet wide. So each one of these okay, so my total area would be 9 times 14. And 9 times 14 is 126. My window area, I've got 2 of these, right? So one window is going to be 4 times 3, width times length. But remember, I've got 2 of these, so I'm also going to multiply by 2 because I got to do this twice. So 126 minus 4 times 3 is 12 times 2 is 24. And 126 minus 24 is 102. Okay, this incomplete table shows how many feet a product on a conveyor belt can travel in a given number of minutes. So I've got the number of minutes and I've got how far it can travel in those minutes. These numbers are all in proportion to each other. So I can say the number of minutes and how far it travels equals another number of minutes and how far it is going to travel. Does that make sense? We've talked about things in proportion and things in ratio. This is really similar to those triangle problems. You just need to make sure we can label this X and this Y, right? And we just need to make sure that this X3 matches up with this Y675. And this X5 matches up with this Y, which is D, because we don't know what it is yet. So now we've got a fraction, an equal sign, and a fraction, which means we can cross multiply. 3 times D is 3D. Then we bring the equal sign down. 5 times 675, which is 3,375. So that was cross multiplying. If I've got a fraction on this side, on the left side of the equation, and a fraction on the right, and they equal each other, I can cross multiply. But now I've got 3 times D, and I want to cancel out the 3. So if I'm multiplying on the top, I need to divide so that I can cancel those out. But if I'm dividing on the left, I have to divide on the right. So 3,375 divided by 3 is 1,125. All right, that is the warm-up. If you have any questions, you can ask Miss Laura, and she can walk you through how to do it. She may have a different way. For number 10, there's actually about 3 different ways that you can do it. You can do these ratios, or you can do distance equals rate times time. And we would call this one distance, and we would call this one time. And so we're trying to figure out what the R is, and then that same R could be used for any of these numbers. So a couple of ways that you can do it, but if you have questions, ask her. If there's anything else you need from me, remember you can send me a text or you can send me an email. I can't guarantee I'm going to get back to you super fast, but I definitely will get back to you. I hope you're doing well. I can't wait to see you when we all get back, and yeah, have a good day.